Hey guys, got requested to make a video for 9, 10, 11. So here's 9, 10, 11. On this one, this is quadratic form right here, so I'm just going to factor it. So I'm going to say e to the x and e to the x. If I multiply those two, it'd give me e to the 2x, which is what it says. I'm going to put a -2 and a -1 because those two add up to be -3, and then multiply to get better to be 2. So my answer is going to be e to the x is 1 or e to the x is 2. Got to solve both of those. The way you solve those, you just do natural log of both sides. Natural log of both sides. Now that first one, natural log of 1, that's all, remember that cancels there, by the way. Natural log of 1 is always going to be 0 because anything to the 0 power is 1. You can punch the other one in your calculator, so I'm about to punch in natural log 2. Let's see what I get. Natural log 2. I'm getting 0.69, I don't know, 0.6931. All right, and those are your two solutions there. Number 10, if you're going to prove that, remember this is called math induction. First thing you do is you got to prove it works for 1. So I'm going to plug a 1 into that right-hand side. I get 1 times 1 plus 1, which is 2. And because that's the first term, it does work for 1. The next thing you have to do is prove that it works for the next term. And the next term is the term after 2n, which, by the way, is 2 times n plus 1. And if I add this to the left-hand side, you must also add it to the right-hand side, which right now is n plus 1. So I'm also going to add the 2 and n plus 1. Now don't forget where you're trying to end up. The way you want to end up is that right-hand side. You want to replace both n's with n plus 1. So I'm going to work with this right-hand side. I'm going to distribute first. And I want to end up with an n plus 1 and then an n plus 1 plus 1. Add my n's in the middle. This should be a 2, by the way. Plus 2, factor it, gives me n plus 1 times n plus 2. Now, the reason I wrote it that way is because there's my n plus 1, which is what I wanted right there. Now, n plus 2 is exactly the same thing as n plus 1 plus 1, which is what I wanted it to be. Okay, because that is the same thing as n plus 2, which is, look at that right there. Look where we started, look where we ended. All of my n's got replaced with n plus 1s, which is an inductive proof. That was awesome. All right, last one, number 11. Number 11 says, suppose you pay $10,000 in an account that pays 8% per year, compounded quarterly. How long will it take to double? Okay, if you're going to double 10,000, that means you're going to end up with 20,000. You could actually skip this step. The formula 1 plus R over N, the rate's 8%. It says compounded quarterly, that's 4. I'm putting 4T because we're looking for the time. Start off by dividing 10,000 into 20,000, that's 2. I'm also going to work out what's inside my parentheses. 1 plus 0.08 divided by 4. I'm getting 1.02 to the 4t power. Now, because I can't make them the same base, I'm going to do ln both sides, ln2. Over here, the exponent goes in the front, natural log 1.02. Now, to finish this up quickly, I'm going to divide both sides by 4, natural log 1.02. Divide that side by 4, natural log 1.02, because that makes everything cancel except for the t. Be careful when you punch that in your calculator. You need to put parentheses off. First of all, around your 2. Secondly, I'd put around the whole denominator if I were you. 4 natural log 1.02, and then close after the 1.02, and you should get like 8.8. It's really 8.75 years to double your money. All right, so there's 9, 10, 11. Hope that helped, and see you tomorrow.